A very good evening to all of you and a very, very warm welcome to BYJU'S Government Exams Prep YouTube channel, where we coach you free of cost for all the forthcoming banking as well as government examinations. तो चलिए आज का टॉपिक देखते हैं जो कि अति महत्वपूर्ण है. It's a very important topic and that is number system part 2. If you remember, in the very first part of number system we had discussed divisibility rules. Now taking up the second part, we will discuss variety of questions including cyclicity as well as LCM HCF. तो अब ये जो दूसरा भाग है संख्या पद्धति का, यहाँ पर हम और भी बहुत सारे वैरायटी ऑफ क्वेश्चंस देखेंगे, साइक्लिसिटी देखेंगे और LCM HCF लघुत्तम समापवर्त्य और महत्तम समापवर्तक. तो ये सभी आज की हमारी लर्निंग्स होंगी. चलिए शुरुआत करते हैं बिल्कुल बेसिक से. सो एज वी नो, इफ वी टॉक अबाउट द नंबर ट्री, तो उसमें अगर हम बात करें तो इंटीजर, जिसे हम हिंदी में पूर्णांक भी बोलते हैं. सो व्हाट इज एन इंटीजर? इट इज अ कंप्लीट नंबर इन काउंटिंग, और लेट अस से it is a number which can be expressed in P by Q form, where Q is equal to 1. Denominator is 1. 2 by 1, 2. 5 by 1, 5. 101 by 1, 101. All right. 1000 by 1, 1000. These are all integers. All right. So integers again are three types. You have positive integers, then you have negative integers, then you have one integer which is known as neutral integer. Now, what is that neutral integer? Obviously, 0. So, numbers greater than 0 are positive integers, and integers lesser than 0 are negative integers, as we are aware. So, then we have, in positive integers, we have a bifurcation again. We have natural numbers and whole numbers. Now, what are natural numbers and what are whole numbers? Now, natural numbers are counting numbers, starting from 1, 2, 3, 4 and so on till infinity. So, they are essentially positive integers. तो आप सब जानते हैं कि प्राकृतिक संख्याएं, या जिन्हें नेचुरल नंबर भी कहा जाता है अंग्रेजी में, तो ये सभी पॉजिटिव इंटीजर्स होते हैं, काउंटिंग नंबर्स होते हैं, गणना वाली संख्या होती हैं 1, 2, 3, 4 से लेकर आगे बढ़ते हुए. Then what is a whole number? Whole number is nothing but it is natural number along with a 0. So whole numbers, they start with 0, then 1, 2, 3, 4, 5, 6 and so on. So the only difference between whole number and natural number is that in whole numbers there is a 0. So you can say that, now listen to me carefully. Now you can say that every natural number is a whole number, but not the vice versa. You can't say every whole number is a natural number. Why? Because 0 is a whole number, but it is not a natural number. But the other way around, you pick up any natural number, obviously it is going to be a whole number. So natural number is a subset of whole number, or it is contained in whole number. तो प्राकृतिक संख्याएं जो होती है, natural number जो होते हैं, वो whole number के अंदर ही होते हैं, ये समझ लीजिए. Then in natural numbers you have two more distinctions: even numbers, odd numbers. As we have learned, you know it very well, which are even numbers divisible by 2, odd numbers not divisible by 2. So we start with 2, 4, 6, 8, 10 and so on. These are even numbers. 1, 3, 5, 7, 9, 11. These are odd numbers. So we are very much aware of these basics. Wonderful. Now then we had also discussed about prime numbers. अभाज्य संख्या के बारे में भी हमारी बात हुई थी और उसमें हमने ये पाया था. Am I audible? Just check once. And prime numbers are those numbers which have exactly two factors, itself and 1. तो अभाज्य संख्याएं वो होती हैं जो केवल दो ही संख्याओं द्वारा भाग होती हैं, एक तो खुद से और दूसरी संख्या 1 से. Then what are composite numbers? Composite numbers are those numbers which have at least 3 factors. One factor is number 1, the other factor is the number itself, and the third factor could be any other number. Like we have 25. Now 25 here is a composite number. How it is divisible by 25? It is divisible by 1. It is also divisible by 5. All right. Then similarly, there are certain rules, as you people are aware. Addition plus addition is addition. All right. Or positive plus positive is positive. You can say that. Positive plus negative is positive or negative, depending on whichever is greater. If the if the magnitude or value of positive number is greater than the magnitude of negative number, then your answer has to be in positive. And similarly, if at all there is a negative number which has a greater magnitude than the positive number, then your answer will be negative. Then finally, if at all you add two negative numbers, then the answer is negative only. तो दो negative numbers को अगर आप add करोगे तो आंसर हमेशा नेगेटिव ही आएगा. दो ऋणात्मक संख्याओं को अगर जोड़ा जाए तो उनका योग जो है वो ऋणात्मक संख्या ही होती है. Now similarly, as you people are aware, if you multiply the product of, let us say the product of two positive numbers is positive, product of a positive and a negative is always negative, and product of two negative numbers is always positive. Very, very basic. Now the important formulas. Very much in use, first of all, in various questions, and there could be a question in particular pertaining to these formulas. तो ये फॉर्मूले जो हैं ये बड़े इंपॉर्टेंट है जी, याद रखें इनको. इनका बहुत उपयोग होता है अलग अलग प्रश्नों में, और इसके अलावा इन्हीं पे कई बार प्रश्न भी आ जाते हैं. तो आइए देखते हैं. सम ऑफ इनिशियल एन नेचुरल नंबर्स, शुरुआती n प्राकृतिक संख्याओं का जोड़ या योग हमेशा n इंटू n प्लस वन बाई टू इस विधि द्वारा प्राप्त किया जाता है. इट इज ऑब्टेन्ड थ्रू द फॉर्मूला n इंटू n प्लस वन बाई टू. ऑलराइट, very, very widely used, I would say, and very easy to remember as well. N into n plus 1 by 2. Clear? So the next one is sum of squares of n initial natural numbers. Right. Now again, this is nothing but n into n plus 1 into 2n plus 1 whole divided by 6. See, n into n plus 1 you already have. Now there is only one extension, 2n plus 1, and then divided by 6. तो n plus 1 तो आप यहाँ भी देख पा रहे हैं. ठीक, तो उसको आगे मल्टीप्लाई कर दें 2n प्लस 1 और डिवाइड कर दें 6 से. देन सम ऑफ क्यूब्स ऑफ एन इनिशियल नेचुरल नंबर्स, शुरुआती n प्राकृतिक संख्याओं के घनों का योग. सो इफ यू रिमेंबर द फर्स्ट फॉर्मूला, दैट इज सम ऑफ n नेचुरल नंबर्स, n इंटू n प्लस 1 बाई 2, यू जस्ट हैव टू स्क्वायर इट. अगर आपको ये वाला फॉर्मूला याद है, जो कि होना भी चाहिए, बस आपको इसका वर्ग लेना है और आपको शुरुआती n प्राकृतिक संख्याओं के घनों का जोड़ मिल जाएगा. सो n इंटू n प्लस 1 बाई 2 होल स्क्वायर. ऑलराइट, नाउ दैट विल गिव यू द सम ऑफ द क्यूब्स ऑफ इनिशियल n नेचुरल नंबर्स. नेक्स्ट, सम ऑफ इनिशियल n even numbers. Well, when we are talking about initial, if at all it would have been only natural numbers, the sum would be n into n plus 1 by 2. Now because we are talking about alternate numbers, which are those alternate numbers? Even numbers. Alright, so here forget about the denominator 2. जो हर है उसकी संख्या जो 2 है वो भूल जाइए इसमें, और बाकी जो ऊपर का जो बचा हुआ है अंश में, numerator, that is n into n plus 1 is sum of initial n even numbers. Now see, sum of initial n odd numbers, that is n square. Now see, there is a wonderful thing about mathematics here. This is one number, all right? The sum obviously is 1. If I take the first two odd numbers, 1 plus 3, okay, what is the sum? It is 4. Now what is that? 2 square. 1 you know is nothing but it is 1 square. Now sum of first 3 odd numbers, that is 1 plus 3 plus 5, all right, that is nothing but 9, so it works out to be 3 square. Sum of first 4 odd numbers, see, 1 plus 3 plus 5 plus 7, maybe some of you might not have noticed this. Now this is so simple. Sum of first 5 odd numbers, 1 plus 3 plus 5 plus 7 plus 9, that is 25, which is nothing but 5 square and so on. So now if I ask you what would be the sum of first 12 odd numbers, so only thing that you need to do is take 12 square, which is nothing but 144. You don't have to add on to all these numbers. If I ask you what will be the sum of first 25 odd numbers, obviously you're not going to write all the 25 odd numbers, initial 25 odd numbers, isn't it, sir? So what would you do? You would just take a 25 square. आप 25 का वर्ग लेंगे, 25 का स्क्वायर लेंगे 25 का, जो कि आएगा 625. That is the answer. As simple as that. Now, sum of squares of initial n even numbers. शुरुआती n सम संख्याओं के वर्गों का योग. अब इसके लिए आपको याद होना चाहिए शुरुआती n प्राकृतिक संख्याओं के वर्गों का योग. Now for this you must memorize the squares of initial n natural numbers, which we know is this. Alright, now see, this is just an extension of this. Now you know that the sum of n or initial n natural numbers is n into n plus 1 into 2n plus 1. This we are aware. Now you need to find out the sum of squares of n initial even numbers. Alright, then in that case 6 you know is what? 3 into 2. Take this 2 in the numerator. That's all that you need to do. So you multiply with this n into n plus 1 into 2n plus 1. Forget about 6 in the denominator. Just multiply this with 2 by 3. Job done. Alright. Now this is something that you need to memorize. Sum of squares of initial n odd numbers. शुरुआती n विषम संख्याओं के वर्गों का जोड़. That is nothing but n into 4n square minus 1 by 3. उसको बार बार एक बार लिखें आप, and then I think you should be able to memorize it. Alright, so just write it down. Just write it down three times. N into 4n square minus 1 by 3, n into 4n square minus 1 by 3, n into 4n square minus 1 by 3. That's it. You'll be able to memorize this. Alright. So you are asked questions based on these formulas. So you have to learn them by heart. चले जी फटाफट से ये क्वेश्चन सॉल्व करते हैं. What will be the sum of first 50 natural numbers? So what is it that you're going to do? N into n plus 1 by 2. This is nothing but this is also denoted as sigma n. Sigma means summation here. Sigma is a symbol which is used for summation, alright, of n natural numbers. So here the value of n is given to you as 50. आपको 50 दे रखी है यहाँ पर वैल्यू, तो 50 into 51, 50 into 51 by 2 goes by 25. So 25 into 50 is 1250 plus another 25. So this should be 1275, which is given to us in choice C. Very simple one, just substitution in the formula. All right. Now look at this question. What will be the sum of first 20 even numbers? I told you the summation of n even numbers is nothing but it is n into n plus 1, not by 2. Alright, that is sum of natural numbers. तो यहां पर आप देख रहे हैं कि n की वैल्यू क्या है? n की वैल्यू यहां पर है 20. So similarly it becomes 20 into 21. That's all. Choice D here should be the correct answer. Substitution, simple substitution. Alright, now what will be the sum of first 20 odd numbers? Now how do you find out the sum of first 20 odd numbers? I told you summation of n odd numbers is nothing but it is n square. So your answer here is 20 square, which is 400. Choice C is the answer. As simple as that. Quite simple, isn't it, sir? So now let us move ahead and look at some more questions of similar sort. Now what will be the sum of squares of first 10 natural numbers? Now what was the formula for that, if you remember? Sigma n square, that is n into n plus 1 into 2n plus 1 by 6. So the value of n here is already declared as 10. So this becomes 10 into 11 into 21 by 6. See, this is 10 here. So 2 into 10, 20 plus 1, 21. All right. So no need to cancel here. You can just cancel here with 3 if you want. Okay. But don't cancel this 10 into. Why? If at all in numerator especially, you have 10 into something, then let it remain as it is. अगर आपको कभी भी न्यूमिरेटर में 10 into something आ जाता है तो उसे वैसे ही रहने दे. Do not cancel 10 with any number present in the denominator. Reason, when you will multiply these, what you will get is a number followed by a 0 because you are multiplying with 10. So you basically have a 770 by 2. Right, quite simple to find out. So 700 half is 350. 70 the half is 35. So 350 plus 35. So your answer here should be 385, which is given to us in choice B. Okay, so what will be the sum of cubes of first 10 natural numbers? So that is nothing but sigma n cube, for which I told you employ the formula for sum of n natural numbers and then square it. Take the square of that. So what should it become? It should become, the value is 10. So 10 into 11 by 2 whole square. Alright, so here no problem, you can cut it. So what you basically have is a 55 square, which you remember is nothing but 5 into 6, 30, followed by a 25. Choice C here becomes our answer. Alright. So now let us have a look at this question, which I want you to solve on your own. Alright, so I'll give you some 10 seconds. Please hurry up. Okay, let's start this. So it is given 1 square plus 2 square plus 3 square so on till 10 square is 385. Alright, so 2 square plus 4 square plus 6 square till 20 square, even number square. Okay, so maybe you could have just used a formula to find out the squares of even numbers. आप यहाँ पर जो भी even numbers दिए गए हैं उनके squares का इस्तेमाल कर सकते थे sum का. Formula क्या था? See, sum of squares of even numbers. Alright, so that was nothing but 2n into n plus 1 into 2n plus 1 by 3. That's all that you have. So if you use the formula, you know that the value of n here will be 20. So it would be a little cumbersome. Okay, and that is again here a 20 into 2. In fact, these are 10 numbers. I'm sorry. We can take them as 10 numbers. Alright, so we know that these are first 10 natural even numbers. Okay, so you can have a 2 into 10 into 11 into, this is 10, 21 whole by 3 goes by 7. So 7 into 11, 77, into 2, 154, and you have a 0 in front of that. So you have a total of 1540. That is one method. The other method here could be that from here, if you take 2 square as common, then what are you left with? Look, 1 square plus 2 square plus 3 square and so on plus 10 square. That's all. Okay, the same thing I'm talking about here. So this is 4 into, see the value here is already given to you here as 385, the sum of these, isn't it so? Okay, so 4 into 385 is what I get, which again 4 5s are 20, 4 8s are 32, so 34, 3 4 3s are 12, 1 5 4 0 is again what we get. So either of these two you could have employed. Alright. Now, what will be the sum of all the natural numbers from 75 to 97? Now, I'll give you some 10-15 seconds. Please find out. Hurry up. Don't write them down and literally don't add them up. All right, guys, let's have a look here. Now here you're not supposed to find out the sum of natural numbers from 1 to 97, but that still will be used. So 75 to 97, if you need to find out the sum, it will be 75 plus 76 plus 77 plus 78 and so on, so on, so on till 97. Literally adding up would mean that you would be solving only 1 to 2 questions in the examination. Okay, so just take the reference from here. I say 1 plus 2 plus 3 plus so on plus 74 plus 75 plus 76 plus so on plus 96 plus 97. What are these? This is the sum of natural numbers from 1 to 97. Okay, now careful look. Careful look. What is it that we need? We actually require this. 75 to 97. So what will you do? Well, first you will take sum of all the numbers from 1 to 97. From that, you will subtract the sum of all the natural numbers from 1 to 74. See here, up to here. Alright, so what will be remaining? Sum of natural numbers from 75 to 97. So what is the sum of first 97 numbers? So I would say sum of numbers from 1 to 97 minus sum of numbers from 1 to 74. Now that being equal to sum of numbers from 75 to 97. So what will be sum of numbers from 1 to 97? It will be 97 into 98 by 2. What? N into n plus 1 by 2, right? Minus sum of numbers from 1 to 74. So value of n here is 74 now. So 74 into 75 by 2. This should give us our answer. All right. So what would this become? 97 into 98. If you remember, I had already taught you in speed maths class, 97 into 98, the very first class, which you would find at the end of the playlists also, the very last class. So subtraction, subtract 100 from each of these. So this is minus 3 and this is minus 2. So 97 minus 2 is 95 or 98 minus 3, either of these. And minus 3 into minus 2 is 06. So 9506, so this is not a hard calculation at all. We have already learnt it, if you remember. Okay. So what you have here is a 9406. 74 into 75. Now you know 75 square. Now how much is 75 square? It is 7 into 8, 56 followed by a 25. That's it. Now I have taken 175 extra. Why? Because it is not 75 into 75. It is 75 into 74. So having taken 175 extra, यहाँ पर 75 minus कर देते हैं जी. So what you get is a 5550. So from, let us say, 9506, you have to first reduce 5550, and whatever you get here, you divide it by 2. So you have a 6, you have a 5, you have a 9, and you have a 3. So you divide this. So 2 ones are 2, 19, so goes by 9. So 15 goes by 7, so 16 goes by 8. 1978 seems like a year, isn't it? So it was a year. So that becomes the answer here. All right. So you should be able to find out solutions to such kind of questions. How did we do that? First we found out sum till 97, then reduced sum from 1 to 74. All right. So remaining would be sum from 75 to 97. That is very simple. All right. Now just try and find out the answer to this question. Hurry up. I'm giving you 10 seconds. Chalo ji, let's start. It says sum of all the 2-digit numbers will be. So basically we are saying 2-digit numbers, they start with 10. So plus 11 plus 12 so on plus 98 plus 99. So the smallest 2-digit number is 10. The highest 2-digit number is 99. So this is what you want. Alright. What did we skip? Well, we skipped 1 plus 2 plus 3 so on till 10. So employ the same method. Alright. And what is that? We will take sum of numbers. So let me just write it in short. Okay. Sum, let us say from 1 to 99 minus sum of numbers from, let us say, this one we have to reduce. Okay. That is 1 to 9. Now this will give us sum of all the numbers from 10 to 99. That is what we will get. So 1 to 99, and here is nothing but it is 99. Okay. What will be the sum? 99 into 100 by 2 minus, here the value of n is 9. Okay. So it is 9 into 10 by 2. Alright. Now this will give us the answer. So by 2, divide by 2 we will do later on. So simple as that, you have a 9900 from which you have to reduce a 90. So you get a 9810 which you have to divide by 2. Alright, so 4s are, so 18, so 9s are, so 1, so a 0, a 10, that is 5. So 4905. That is what we should get, which is given to us in choice D. That becomes the answer. Well, if at all you are in doubt, then please go ahead and add up these numbers. Choice is yours. Alright guys, try and solve this one. 10 seconds. Please hurry up. Okay, let's do this one. While writing numbers from 1 to 100, how many times will the number 2 get written? Now, you know that from 1 to 100, 2 will appear in units place as well as in the tens place. So units place, how many times will you write 2? Well, 10 times. 2, 12, 22, 32, 42, 52, 62, 72, 82, 92. Yes. And tens place, again 10. Yes. 20, 21, 22, 23, 24, 25, 26, up to 29. Now don't say, sir, 22 we have counted. No, 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 no. We counted the units place 2 in 22. But in 22, there are 2 2s. Is it or not? So in tens place 10, in units place 10. So total we get here is a 20. Alright. Now he is not asking you in how many numbers the number 2 will be written. If that would have been the question, then our answer here will be 19. I repeat, if the question would have been in how many numbers from 1 to 100, in how many numbers the digit 2 will appear. If he is asking you the count of numbers, then 22 is only one number, so it will be counted only once. Then your answer will be 20 minus 1, that is 19. But he is asking you how many times will you have to write 2 when you are writing numbers from 1 to 100. In tens place you will write 10 times, in units place you will write 10 times, simple. Okay. Now, just find out this one. Another 10-15 seconds. Please hurry up. Okay, let's start. How many digits are required to write down all the numbers from 1 to 50? 1 से लेकर 50 तक सभी संख्याएं लिखने के लिए कितने अंकों की आवश्यकता है? तो भाई 1 से लेकर 50 तक तो आपके पास में सिंगल डिजिट नंबर भी हैं और डबल डिजिट नंबर भी हैं. While writing down numbers from 1 to 50, you will write down numbers which are single digit and which are double digit. All right. So, one digit numbers are how many? Well, they are from 1 to 9. 1 to 9 are how many numbers? 9 numbers. In each of these 9 numbers, how many digits are there? Only one digit is there. All right. So, total number of digits? 9. Two digit numbers are from where to where? 10 to 9, 10 to, in fact here I have to write till 50, no? 10 to 50. How many numbers are these? 50 minus 10 plus 1. These are basically 41 numbers. Isn't it so? 50 minus 10 plus 1. Isn't it so? 1 to 10, how many numbers are these? 10 minus 1 plus 1. 10 numbers. Is it or not? 10 minus 1 is 9, no? You can't take difference between the two alone. Take the difference, add 1. Take the difference, add 1. Then both 10 and 50, both the values will get included. तो 50 में से 10 निकाल कर एक जोड़ दें तो 50 और 10 दोनों ही इंक्लूड हो जाएंगे. ठीक, दोनों ही सम्मिलित हो जाएंगे. So now these 41 numbers are all two-digit numbers. So how many? Well, 82. Okay. So total digits that would be written from 1 to 50 if you write down all the numbers will be 91, which is given to us in choice C. That should be the answer. All right. So I hope this is clear. Now similarly, on the similar concept, now I'm giving you a bigger number, 1024, 1 to 1024. How many digits will be required to number the pages of a book from 1 to 1024? एक पुस्तक के सभी पृष्ठों पर 1 से 1024 तक की संख्या अंकित करने के लिए कितने अंक चाहिए होंगे? चलिए बताएं. चलिए शुरुआत करते हैं. बिल्कुल वही प्रोसेस. सिंगल डिजिट नंबर कहां से कहां तक है? वी हैव द नंबर्स फ्रॉम 1 to 9. ऑलराइट. नाउ हाउ मेनी नंबर्स आर दीज? These are 9 numbers, each of 1 digit. So we get total 9 such digits for writing down numbers from 1 to 9. Next, we have 2-digit numbers. 2-digit numbers will be from 10 to 99. All right. How many numbers are these? 99 minus 10 plus 1. That is 99 minus 10 is 89 plus 1, 90. So these 90 numbers each will be of 2-digit. Okay. So we get a 180 such digits we will have to use to write numbers from 10 to 99. All right. Next, we also have 3-digit numbers. Isn't it so? From where to where? Well, we have them from 100 to 999. How many numbers are these? 999 minus 100 is 899 plus 1. That is 900. 999 minus 100 plus 1. That is 899 plus 1. We have 900 such numbers and each number consists of 3 digits. So we have a 2700. Correct? Then you have 4-digit numbers. Alright? 4-digit numbers from where to where? You have numbers from 1000 to, already given to you, till 1024. How many numbers are these? 1024 minus 1000 plus 1. 1024 minus 1000 plus 1. That is 25. Alright. So you have 25 such numbers and each of these has 4 digits. So how many digits will be required to write down these 25 numbers? Well, 100 digits. That's it. Alright, so add up all these. You get a 9 here in the units place. Okay, done. So 8 and then you have a 0 here. So 8. So done. Then you have a 1, 7, 8 and 1, 9. Alright, and finally you have a 2 here. Is it? So here we have 2989, just ignore the choices here. Okay, if you are not able to ignore the choices, anyhow, none of these is the answer. Alright, so you can get 2989. This would be the total count of all the digits. Now, I come on to a very important concept that is called cyclicity of numbers. Alright, now what do you mean by cyclicity of numbers? Cyclicity of numbers का मतलब ये है कि हर एक पावर के बाद में यूनिट्स डिजिट में कौन सा डिजिट आता है यूनिट्स प्लेस पे. दैट इज इन एवरी सिंगल पावर ऑफ अ नंबर which digit will appear in the units place. Now, why do we require such questions? Well, you have a look at the question. I would just show it to you. You tell me which digit will come in the units place in 57 raised to 243. Is it or not? You are not going to literally calculate it. All right, your calculator also can't do this. Okay. So now how to handle such questions? Okay. So now look at these numbers which I am giving you here. So I am starting with 2. You know that 2 power 1 is 2. 2 power 2 is 4. 2 power 3 is 8. 2 power 4 is 16. All right. So I am just writing down the units digit. 16. All right. So which digit appears in the units place? 6. All right. Now again, if you write 2 power 5, you will get 2. 2 power 6, again you will get 4. 2 power 7, again you will get 8. 2 power 8, again you will get 6. 2 power 9, again you will get 2. So as you can see here, the cyclicity for the number 2 is 4. It has a cycle of 4. What do I mean by that? After every fourth power, the units digit will repeat. After every fourth power, the units digit will repeat. So here 2 power 1 is 2. So 2 power 5 is 2. 2 power 9 is 2. So plus 4. 2 power 13 will be 2. 2 power 17 will be 2 in the units place and so on. And as you can notice, the cyclicity of 2 here is ending in 6. Is it or not? So I can say that it has a cyclicity of 4, or let us say that the units digit will repeat after every fourth power. All right. So groups of 4. Group of 4, 2 power 1, 2, 3, 4. 2, 4, 8, 6. Then again 2 power 5, 6, 7, 8. 2, 4, 8, 6. Then again 2 power 9, 10, 11, 12. 2, 4, 8, 6 and so on. This will keep on recurring. So there is a cycle of 4 here. All right. Now next I am picking up 3. 3 power 1, 3. 3 power 2, 9. 3 power 3, 7. And 3 power 4, again 7 3s are 81 or 21. I mean 3 power 4 is 81. Then again 3 power 5, 1 into 3 is going to be 3. So once again here we find out that for 3, 3 has a cyclicity of 4. So after every fourth power, the units digit will repeat. So 3 power 1, 2, 3, 4, 3971. 3 power 5, 6, 7, 8, 3971. 3 power 9, 10, 11, 12, 3971. This will keep on repeating. Alright, and here it is ending at 1. For 2, it is ending at 6. For 3, it is ending in 1. What do I mean by ending in 1? The last power in this group. The last power in this group has 1 in the units place. The last power in this group for 2 has 6 in the units place. Now this also has a significance, what I am telling you. So later I would tell you about it. Alright. Now let me take the next number here. Next number which I am taking here is 8. Okay. I could have taken 4. I will take 4. Don't worry. So 8 power 1, 8. 8 power 2, 64, no? So I have a 4 here. 8 power 3, multiply 8. 8 4s are 32, so 2. 8 power 4, again 8 2s are 16. 8 power 5, 8 6s are 48, again 4. Again 8 will repeat. Alright, so here also I would say for 8, 8 has the cyclicity of 4. I hope this is clear. Alright. Now let us take up 9. So 9 power, no, not 9. I will take up 6. No, 7. 7. Let me take up 7. 7 power 1 is 7. 7 power 2, 49 होता है, तो 9 आ गया. 7 power 3, 7 9s are 63. 7 power 4, 7 3s are 21. Again 7 power 5, 7 1s are 7. So here also there is a cyclicity of 4 for 7. I hope this is clear. All right? Okay. Now let me take the other numbers in between. So 2, 3, I am taking up 4. So 4 power 1 is 4. 4 power 2 is 16. Again 4 power 3 is 64. Again 4. Is it or not? And then again 4 power 4. Alright, so it is nothing but, let us say 256. So again 6. So now here you see 4, 6, 4, 6, 4, 6 will keep on repeating. So here for 4, it is a cyclicity of 2. That is, after every second power, the units digit will keep on repeating itself. हर दूसरी पावर के बाद में इकाई के स्थान पर, यूनिट्स प्लेस पर, जो संख्या है, जो भी अंक है, वो रिपीट होता जाएगा, दोहराता जाएगा अपने आप को. Now similarly, have a look at 9. 9 power 9 is, 9 power 1 is 9. 9 power 2, 81, so again 1. 9 power 3, so 9 ones are 9, again 9. 9 power 3 is 729. Is it or not? Okay. So again 9 power 4 will again have 9 9s are 81, so 1. So 9 1, 9 1, 9 1. So these two numbers will keep on repeating themselves after power of 2. So I would say after every second power, the digit, units digit will get repeated. So cyclicity of 2 is what I have here. All right. So 2, 3, 4, 7, 8, 9 done. We are left with two numbers 5 and 6. Well, why I took them a bit later is 5 to the power of n. You will always get 5 in the units place. Now similarly, 6 to the power of n, you will always get 6 in the units place. See, 6 power 1, 6. 6 power 2, 36. 6 power 2, 216. Alright, 6 power 3, 216. So likewise, 5 power 1, 5, 5 power 2, 25, 5 power 3, 125, 5 power 4, 625. So again you will always get 5. So here for these two numbers, you will always get a cyclicity of 1. I hope this is very clear to you. All right, so I would say cyclicity of 4. Now there are 4 numbers which have cyclicity of 4. Which are those? 2, 3, 7, 8. हिंदी में याद कर लो यार 23, 78 है ना 2, 3, 7, 8. And apart from that there is another way, no? See, complements of 10. 2 plus 8 is 10, 3 plus 7 is 10. That's how it is. All right. So 2, 3, 7, 8. These 4 numbers will always have cyclicity of 4. Now cyclicity of 2 will be the 2 squares. See, 4 here is a square. 9 here is also a square. It's a 3 square. So we have only 2 squares which are 1 digit here, except 1. I'm not talking about 1 here. Starting with 2. 2 to 9, you know, these single digit numbers, 2 of them out of these are squares. Which are those? 4 and 9. For these squares, cyclicity will always be of 2. Okay. So cyclicity here is what? It is of 2. For 4 and 9. Cyclicity of 1, you have 5 and 6. And obviously 1 also. 1 power n, you will always get 1 actually. Isn't it so? So this is something you have to keep in your mind while solving questions. Now, how to solve the questions? All right. So 57 raised to 243, just remember this. So what I'm going to do is I'm going to introduce another sheet here. So it was 57 raised to 243. Later on we will do this. I ask you, which number will come in the units place digit for, let us say, 2 power 63. All right. Now what do? See, what you have to do is, you know that cyclicity of 2, okay, and if at all you have seen the previous sheet, you would know cyclicity of 2, 8 and 6. All right, they always end 2, 4, 8, 6. Cyclicity of all the even numbers here, 2, 4, 8, 6. They end in 6. Is it or not? As you might have seen previously. I will show you on the next slide also. Whereas cyclicity of odd numbers like 3, 7 and 9, leave 5. 5 will always result in 5. But cyclicity of numbers 3, 7 and 9 will always end in 1. So cyclicity of even numbers will end in 6. Cyclicity of odd numbers will end in 1. So I would just write that. Cyclicity of 2, 4, 6, 8 end in 6. And then cyclicity of 3, 7 and 9. Just a minute, let me make it look better. All right, it's a little shabby. This will always end in 1. All right, so having said that, you know this can be expressed as, 63, what I'll try to do is, I would divide this by 4. So what I get here is a 4 into 15, that is 60 plus 3. Okay, so 15 groups of 4 each. So this is nothing but this is 2 power 4, okay, plus 2 power 3. 2 power 4 into 15 is 2 power 4 only. Why? The units place. Why? Because these are groups which are getting completed and they always complete in digit 6. Cyclicity of 2, 4, 6, 8 end in 6. So cyclicity of 2 ends in 6. and it has a cyclicity of 4. Okay, so 2 power 4 is 6 plus 2 power 3 is 8. Isn't it so? So in fact, I should multiply, I'm sorry. So 6 8s are 48. All right, so this is what we should get here. Okay, now I just want you to know this, that why should you keep on dividing by 4? 4 into 15. 15 is not essential here. The quotient is not required. Now listen to me carefully. When you have a power here, 2 raised to 63, I want you to find out the nearest multiple of 4. To which number? To 63. So this, in fact, you could have easily written this as 2 power 60 plus 3. Now this is the nearest multiple of 4. In 63, the nearest multiple of 4 is 60. So why do you need to write it as 4 into 15? No, we're not bothered about the quotient 15 here. What we want is a number so that is divisible by 4, the nearest multiple of 4, so that we know till 2 power 60, our cycle is getting complete and it is ending in 6, digit 6. So this, you know, is nothing but 2 power 60 into 2 power 3. All right, 2 power 60 is again 2 power 4 only. All right, because this is multiple of 4. So here this will give us a 6. 2 power 3 is 8, and that is how we are getting a 8, because 6 8s are 48. So 48, 4 we don't want. We want the units place. Units place digit. Digit in the units place. All right, so this becomes easy. All right, so now let us say I want to know 3 power 341. All right, find out the digit in the units place. Now 3 again, if you remember, it has cyclicity of 4. All right, so find out the nearest multiple of 4. And what is the divisibility rule for 4? The number found by the last 2 digits must be divisible by 4. Then the complete number is divisible by 4. So what you get here basically is, you can write 3 raised to 341 as 3 raised to 340 into 3 raised to 1. Is it or not? Yes? See, 40 here, the last 2 digits is a multiple of 4. Okay, so now we know that this is 3 and its cyclicity is 4, and the cyclicity of 3 always ends in 1. So you get a 1 here into 3 power 1, that is 3. So your answer here is 3. So in the number 3 raised, the digit in the units place is going to be 3. Now I take on the question that I had asked you, 57 raised to 243. Okay, so you should be in a position to take up this 57 raised to 243. Ignore this 5 because you want units place. All right, so even if I would have written a number 1 2 3 4 5 7, I don't need that 1 2 3 4 5. I just need the last digit. To find out the last digit, we require the last digit. All right, so this is 7 raised to 243. So this is 7 raised to 240 plus 3. See, nearest multiple of 4 will be 240, right? So again, this is 7 and the cyclicity of 7 ends in 1. All right, why? Its cyclicity is 4, by the way, and it ends in 1. So we get a 1 here. All right, and this is 7 raised to 240 into 7 raised to 3. So this is 1 into 7 raised to 3. What is 7 raised to 3? 343. Is it or not? So you have a 3. So again, your answer here is 3. Now this is how we proceed. All right. Now I'll show it to you what I meant here by ending the cyclicity. See, this is even number 2. Cyclicity is ending in 6. 8, cyclicity is ending in 6. 4, cyclicity is ending in 6. 6, cyclicity is ending in 6. So 2, 4, 6, 8, the cyclicity will end in 6. All right. Now see, 3, cyclicity ends in 1. 7, cyclicity ends in 1. 9, cyclicity ends in 1. 5, by the way, ends in 5 only. So we can't say for all odd numbers. All right. So 2, 4, 6, 8, even numbers, cyclicity will end in 6. 3, 7, 9, these odd numbers except 5, the cyclicity will end in 1. Now apart from that, you remember that 2, 3, 7, 8, it has cyclicity of 4. The 2 squares 4 and 9 will have cyclicity of 2, and the numbers digits 5 and 6 will have cyclicity of only 1. All right, 5 raised to any power, you will get 5 in the units place. 6 raised to any power, you will get 6 in the units place. तो ये बहुत आसान हो गया भाई, याद रखना भी, है ना? तो चलिए इस पे क्वेश्चंस बनाते हैं. इससे पहले छोटा सा रिवीजन, जैसे आपके सामने है 2 is 2, 4, 8, 6 is what you get. 3, 3, 9, 7, 1. 4, 4, 6, 5, 6, same numbers. 7, 8, as I have already told you. So 2 again ends in 6, 4 ends in 6, 6 ends in 6, 8 ends in 6. 3 ends in 1, 7 ends in 1, 9 ends in 1. Cyclicity of 4 is 4. All right. So here, cyclicity of 4, we have 4 such numbers, 2, 3, 7, 8. Cyclicity of 2, there are only 2 numbers, 4 and 9. Cyclicity of 1, there are 2 numbers, 5 and 6. All right. Now let us see if you can solve this question. Now please try it out. I'll give you some 10 seconds, more than enough actually. Nothing is to be done here. All right. See, it is 4387 raised to 245 into 621 raised to 72. So scary. But you are not supposed to find out this product. Which number will occupy the units place? Units place पे इकाई के स्थान पर कौन सी संख्या है, कौन सा अंक है, वो निकालना है आपने. तो घबराना नहीं है यहाँ पर, ये मल्टीप्लाई नहीं करना है भाई. कौन निकालेगा ये? पेपर सेट करने वाला खुद नहीं सॉल्व कर सकता है भाई. Now here, you know this number 621. What does it have in units place? 1. Raised to any number will give you 1 in the units place. Now, 7 is all that we need. Okay. So this is 7 raised to 245 into 1. Okay, so ignore this one. It's not required. All right. Now here what do? You find out the nearest multiple of 4. Why? Because the cyclicity of 7 is 4. So you would write this as 7 raised to 244 plus 1. See? Last 2 digits should be divisible by 4, 44. All right. So this can be rewritten as 7 raised to 244 into 7 raised to 1. Yes. Now this anyhow, 7, the cyclicity ends in 1 into 7 raised to 1 is 7. So what you will get here will be a 7. All right. So I hope that nobody is concluding, sir, 7 into 1 anyhow 7. I did it by shortcut. This is not a shortcut. That is a fluke. है ना? So don't do jugaad. Just leave jugaad. You will land in Tihad. Okay? All right. Next question. Let's have a look here. Now try to solve this one. This is what we have. Units place. Come on, guys. Hurry up, hurry up. Super speed. All right, let's solve this one. 7 raised to 71. Okay, so here 7 has a cyclicity of 4. So the power should be divisible by 4 first of all, and then let us see what is the remainder. So nearest multiple will be how much? 68, as you know. All right, you don't have to literally see by dividing 71 by 4. No, 72 is divisible by 4. So 72 minus 4, 68 is divisible by 4. So this can be written as 7 raised to 68 plus 3. This 6 to the power of anything will give you 6 in the units place into 3 power 65. So that is nearest, again 3 has a cyclicity of 4. So nearest multiple of 4. That is 64 plus 1, that is 65, yes. So this basically is nothing but 7 raised to 68 into 7 raised to 3 into 6 into 3 raised to 64 into 3 raised to 1. This is what I got from this expression, no? As simple as that. Now 7 raised to 68. The cyclicity of 7 ends in 1 and the cyclicity is 4. So cyclicity ends in 1, so I get a 1 here. 7 raised to 3, 343, so 3, 1 into 3. Into 6, 3 raised to 64, cyclicity of 3 ends in 1, okay, into 3. So what you have till here, 6 3s are 18. So 8 into 3, 18, I just want the units place. So I took 8. So 8 3s are 24. We should get 4 here as the answer. Alright. So first of all, you know that 3 and 1 cannot be the answer. Why? Because we already have an even number now. Even into odd is even. Isn't it so? So you would definitely get an even number in the unit space. So answer here becomes 4. Alright, so this should not be a problem for you. Now, the remainder, alright, the so-called remainder theorem, alright, it has different forms, but what I'm going to explain here to you is going to be sufficient. Now, what will be the remainder obtained on dividing 3 raised to 21 by 5? So basically, he's asking you 3 raised to 21 when divided by 5, what is the remainder obtained? Again, who's going to, divide 3 raised to 21? So what I'm going to do is, once again, 3 raised to 21, it has a cyclicity of 4. So it will become 3 raised to 20 plus 1 by 5. Alright. So this is nothing but 3 raised to 20. What is 3 raised to 20? The cyclicity is of 4, ends in 1. Then 3 raised to 1, you get a 3, divide by 5. So 3 when divided by 5, the remainder obtained will be 3 only. If you divide 1 by 5, then 1 is the remainder. Number lesser than 5, if you divide by 5, that number itself is the remainder. So 3 divided by 5, remainder 3. 3 is not a number which is larger than or greater than 5, no. Okay, so you get choice C here as the answer for you. Now see, what will be the remainder obtained on dividing 78 raised to 343 into 86 raised to 729? Divide this by 5. Now please try and find it out very fast. Come on guys, hurry up. Shall we start? All right, guys. Okay, so what you have here is a 78 raised to 343 into 86 raised to 729. You have to divide this by 5 and then you have to find out the remainder. Now mind you, here this number is ending with 7. So do you actually require this 7? Do you actually require this 8? Units place we want, that's all. Okay. So this can be written as 8 raised to, now 8 has a cyclicity of 4. So 343, nearest multiple of 4 is 340 plus 3. 340 plus 3 into, this is 6 raised to anything. 6 raised to anything is going to give you 6 in the units place. That's all that you will do. Alright, this you have to divide by 5. Now 8 has a cyclicity of 4 and it ends in 6. So 8 raised to 340 is going to give us a 6 into 8 raised to 3. 8 cube is 512. So it gives you a 2 into 6 divided by 5. So you have 6 2s are 12. 12, again you have a 2. Okay. So 6 into 6 again you get 6. So 6 into 2 is what? You get a 12. Alright. So divided by 5. So remainder obtained here has to be 2. So I hope this is clear. So huge, big numbers not to be afraid of. Alright. You're not supposed to be afraid of them. Follow simple steps, you get your answers. So that is cyclicity for you. And you get questions at times, based on cyclicity. Now talking about fractions, how you compare them. Which is the smallest fraction among 3 by 4, 5 by 3, 4 by 7, 2 by 3? 10 seconds, please hurry up. Alright, you need the smallest fraction. Okay, now there are two ways. I mean, you take the LCM kind of a thing and then solve it. Alright, and compare them. Rather than that, because I have already taught you fraction to percentage and percentage to fraction conversions. So this should not be a problem for you. Okay. Now 3 by 4 is what? 75%. 5 by 3 is greater than 100%. So anyhow, this cannot be the answer. Why? You need the smallest fraction. 4 by 7. Now how do you find out 4 by 7? You double the numerator. Alright? That becomes 8. So 7 8s are 56. Double of 56. What do you have? 112. So total comes out to be 57.12%. So this is 57.12. 2 by 3. This is, 66.67. This happens to be the smallest. So your answer here happens to be 4 by 7. That's it. Okay. So what do you do if at all you need to, compare fractions, which is smallest, which is greatest? Now in that case, take the, percentage equivalents. That would suffice. Now one thing which I want to ask you, which one is greater? 3 by 8 is greater or 4 by 9 is greater? Which one is greater? Now for this, again, 3 by 8, if you remember, is 37.5%. 4 by 9, is 44.44. So this is greater. Now another thing which I want to tell you here is that A by B, if you have a fraction P by Q, okay, we will take the fraction as P by Q. The most widely used standard form. See, this P by Q will always be less than P plus A by Q plus A. Alright, so just remember that. So 3 by 8 and 4 by 9. What is 4 by 9? It is 3 plus 1 by 8 plus 1. See, this is the value of A. Same number being added to the numerator and denominator. then whatever fraction that you get will be greater than the initial fraction. All right, so let us say if I have a number 5 by 12, okay, and I add 2 to each of the numerator and denominator. So 5 by 12, 5 plus 2 is 7, 12 plus 2 is 14. Now this you know is half, 5 by 12. 5 here is lesser than the half of 12. If this would have been 6 by 12, then half. 5 by 12 is less than half. So hence proved 5 by 12 is lesser than 5 plus 2 by 12 plus 2. 5 plus a by 12 plus a. So P by Q is always less than P plus Q by, P plus A. I'll just correct this. If I could read it incorrect or wrong, then even you could do so. Okay, so proper A I will make. So P by Q is less than P plus A by Q plus A. All right, so remember this. This is again a very useful rule which might be used in some of the questions. Okay, now just find out this one. You just now learned how to solve this. Hurry up, very simple, very simple. We always start with simple questions, don't we? So don't worry about it. See, this is what? 1 by 2 is 50%. Okay, now what is 3 by 7? 3 into 2 is 6. 6 sevens are 42. All right, 0.84. So anyhow, what do you want? You want the number which is greater than 2 by 3. 2 by 3 itself is 66.67. Is it or not? Okay. So, never mind. You still have a 4 by 7. Okay. So, 4 into 2 is 8. So, 7 8s are 56. So, again lesser than 66. No? Then obviously 6 by 7 is our natural choice. Should not be a problem. Anyhow, so 6 into 2 is 12. Okay, so 7 into 12, 84.168. So that is nothing but 85.68. Anyhow, don't need to do that. Here the difference is the least. One thing that you can do is 6 by 7 is anyhow greater than 3 by 7 and 4 by 7. So 3 by 7 and 4 by 7 are out. 6 by 7 is also greater than 1 by 2. Because the half of 7 is 3.5. 3.5 by 7 is half. This is 6 by 7, which is greater than 3.5 by 7. All right, so it is greater than half. So you can check for 6 by 7 directly. Okay, quite simple. No need to compare these three. Okay, that is where you could have saved your time. Now let's try the next question. Have a look at this. Try to solve this. All right, let's start. On dividing a number by 36, the remainder obtained is 19. If the same number is divided by 12, the remainder obtained will be how much? किसी संख्या को 36 से भाग करने पर शेषफल 19 प्राप्त होता है, तो उसी संख्या को अगर 12 से भाग किया जाए तो शेषफल कितना होगा? भाई मान लेते हैं वो संख्या जो है वो x है. Let us assume that the number is x which we are going to divide by 36. So when you divide the number x by 36, the remainder obtained is 19. When the same number x gets divided by 12, what will be the remainder obtained? It's a very simple question actually. Okay, you don't have to assume anything. No assumption. Simple. If the first divider is divisible by the second divisor, see 36 here, the first divisor is divisible by 12. The first divisor is divisible by the second divisor. 36 is divisible by 12. In such a case, directly divide the first remainder by 12. So 19 by 12, you get 7 as the remainder, which should be the Answer, this is a rule. Okay. Now, very easily you can find this out, actually. See, if I, let us say, I'll give you an example, 93. I'm dividing this by 20. Okay. Now, what is the remainder I get? I get a remainder 13. If I divide 93 with 5, okay, what is the remainder I'll get? 3. Is it or not? Now, 20 here is divisible by 5. So, directly divide 13 by 5, no? If you divide 13 by 5, then also your remainder is 3, no? So, if the first divisor is divisible by the second divisor, if the first divisor is divisible by the second divisor, if the first divisor is divisible by the second divisor, then directly divide the first remainder by the second divisor. So, directly dividing 19 by 12 here should give us 7 as the answer. Simple. Okay. So, these are all exam questions that we're getting. Now, try this one out. Similar question. Come on, this is for your practice. Hurry up. All right, very good. So, on dividing a number by 175, the remainder obtained is 132. On dividing the same number by 25, what will be the remainder obtained? Now you see 175 here is divisible by 25. It's a multiple of 25. The first divisor is divisible by the second divisor. The first divisor is divisible by the second divisor. Then what do? You divide the first remainder. You divide the first remainder by the second divisor. So, dividing the first remainder by the second divisor, it goes by 125. So, remainder once again is 7. All right. That is choice B. So, I hope this one is clear for you. You've done 2 questions. You can solve more questions. Create questions on yourself, Just take 2 numbers, one dividing the other. All right, then assume any number. You would see that on dividing the first remainder by the second divisor, you will get the same answer. Okay. All right, just try and solve this one. Please hurry up. Okay, the product of 2 numbers is 36. All right, let the 2 numbers be x and y. So, xy is 36. All right, and x plus y is 13. No need to form any equations. All right, just factorize 36. 36 is 1 into 36. It is 2 into 18. It is 3 into 12. It is 4 into 9. That's it. Oh. Okay, it is 6 into 6 also. Now you see x plus y is 13. So this is where you get 13 over. Why do you need to sweat so hard here? Come on, just factorize this and you would know that x plus y is 13. All right, he says what will be the absolute difference between the 2 numbers. So difference here is how much? It is 5. So choice C is the answer. So you don't have to form equations, by the way, here. X plus y is 13, so x minus y is 36, x is equal to 13 minus y, so then you will substitute it here in place of y, then you will get a quadratic. Why do you need to do all these things? Unless you have a lot of time with you. Now see, solve this question. Use very basic logic. Just be conceptual in your thought. All right, the sum of two numbers is 40. So let the two numbers be x and y. So x plus y is 40. Okay, and the product is 375. So xy is 375. Okay, now some of you might have started factorizing 375. है ना? Just hold it. Read the question first. What will be the sum of the reciprocals of the two numbers? Now, what will be the sum of the reciprocals? First of all, 1 by x plus 1 by y. This is nothing but x plus y by xy. X plus y is given here. है ना? X by y is given here. So your answer here is 40 by 375. That's all that you need to do. Reduce it further. Yes, you can. 5 into 8. So 5 sevens are and then 5. Okay, so 8 by 75 is the answer. Already given, no, x plus y is given. xy is also given. So reciprocals, व्युत्क्रमों का योग पूछ रहा है वो, है ना? तो reciprocals, if you add up, they become how much? X plus y by x by y. X plus y is given 40, xy is given 375. Just substitute answer. That's it. Okay. So there is always an easy solution to a complex problem. And sometimes there are problems which seem easy, but their solution is tedious. All right? It may not be that simple. Now solve this one. Come on, hurry up. All right, it says sum of squares of two positive integers is 100. So x square plus y square is equal to 100. This is the first method. I'll tell you an easier one also. Difference between their squares is 28. X square minus y square is 28. So you have two equations there. All right, so add them. You get a 2x square is equal to 128. X square is equal to 64. The value of x here becomes 8. All right. So now the next number y, how much is that? So y square here is equal to 100 minus 64, that is 36. So y here is 6. Okay, sum of these two numbers is what he wants. That is nothing but 14. Now this is one way. Now if you remember my number series class, you know, when I was discussing the last 33rd question with you, the very last one, that was N series, you remember? In which we were comparing the numbers with their nearest square and nearest cube, all right? In that question I took some numbers like 150, 392, then we had 36, 18, then 100. While telling you about 100, I told you that you must remember that 100 can be expressed as 64 plus 36. It is sum of two squares. Alright, so directly you would have got this, no? 100 is equal to 64 plus 36, which is 8 square, and this is what? 6 square. Correct? So the sum of these two numbers, 8 and 6, is 14, that's it. Directly you would have got it if you would have remembered that logic. If not, then you would have followed this process. You would have lost some seconds here by, you know, following this method when compared to that one. Immediately it would have struck you 100, 64, 36, 8 and 6, 14. Wow. All right, hardly 5 seconds. All right, now solve this one. Very simple, very, very simple question. Okay, so 159 is first multiplied with 367, then multiplied with 482. Okay, so we don't need all these numbers. We need 9 units place. All right, then we need a 7, and then we finally need a 2. So 9 into 7 is 63 into 2. 6 is the answer. There is no power also involved here. A very simple question. Now, I present to you, the consecutive numbers. How do you need to represent them? Now, this is something we discussed during averages as well. So, 3 consecutive numbers, x minus 1, x and x plus 1, and the middle number here, is the average. Okay, so this is what? This is the average. Alright, if you have 5 consecutive integers, this is how you represent them, and again, the middle number here is the average of these 5 numbers, average or mean as you call them. 4 consecutive integers you can write like this, or else you could have written like, x minus 1, x plus 1, or 4 consecutive integers, sorry. Just a minute. Can't have this. There's a difference of 2 here. Well, you can have them like this also. Okay, and here the average would be nothing but, so just revising, average here is x plus 1 by 2, the average of these two. That would be the average of all the 4 numbers. 3 consecutive even or odd numbers, again, this is the average, the middle number. Okay. 5 consecutive even odd numbers, again, the middle one here is the average, just remember that, the middle number here. When we have odd number of numbers, 3, 5, 3, 5. 4 even number of numbers, you always take the average of the middle 2 numbers. Anyhow, the sum of 3 consecutive integers is 54. Find out the smallest integer. See, you need to brighten up your aptitude. It's not always about solving exam questions. It's about, improving upon your IQ level, improving your intelligentsia. All right. So it is not that I will not solve these type of questions, I will solve only this type of questions. That doesn't make sense. Your whole aim here is not only to solve exam pattern based questions, but also to improve and increase your intelligentsia and IQ level. Okay, your problem solving ability. That is what you need to strike or improve upon. Anyhow, the sum of 3 consecutive integers is 54. So x plus 1, x minus 1 and x. Anyhow, so x, if I write them in the correct order, there would be x minus 1, x and x plus 1. Alright, their sum is already given to you as 54. So you find out the smallest number. See, I told you, here the middle number here is nothing but it is the average. Okay, so this number is what? This is 54 by 3. Is it or not? So this becomes 18. So he says sum of 3 consecutive integers. So this is 18, 1 ahead 19, 1 less 17. These are the numbers. So find the smallest number here is 17. That's it. Okay. So your process here is important. Otherwise, you can always keep on increasing the number of steps also. Sum of 5 consecutive even numbers is 100. Find out the highest even number. Sorry. Now once again, either you do it like x minus 4, x plus 2, then x minus 2. I mean, this is one way that you could have solved. X minus 2, then you have plus x plus 2 plus x plus 4. See, even writing this has taken so much of time. The middle number here is the average. Alright, an average here will be 100 by 5, that is 20. So it is consecutive even numbers. So 20 plus 2, 22, plus 2, 24. See, minus 2, 18, minus 2, 16. These are the 5 numbers. This is the average. And the highest even number here happens to be 24, as simple as that. Okay, how many natural numbers between 30 and 200 are divisible by 7? Find out. How many natural numbers between 30 and 200 are divisible by 7? What will you do? Well, 30 to 200, how many numbers are these? 170, 200 minus 30, plus 1, that is 171 numbers. Now after 30, you know that 30 is not divisible by 7. Now in 30 to 200, which is the first number which is divisible by 7, it will be 35. So leave this aside. Now 36 to 200, How many numbers are these? It is 200 minus 36 plus 1. Alright, so these are 165 numbers. Correct? Divide this by 7 now. Okay, so 200 minus 36 is, yes, 165 numbers. So you have a 7 2s are 14. So you have a 25, so 7 3s are 21. Remove that. 23 here, 35 we had taken here. So this 35 plus these 23 numbers, total 24 numbers is what we will get between 30 and 200, which are divisible by 7. Alright? Okay. So how many numbers are there below 1000, which are divisible by both 13 and 10? Both 13 and 10. So take LCM of 13 and 10, which is 130. Alright? So 1000, you'll simply divide this by 130. Remove the 0, no? Not required. Okay? So 13 sevens are 91. Remove that. So we know it only requires 7 here as the answer. So there are 7 such numbers. Which smallest number when subtracted from 36798 will give a resulting number which is divisible by 78? ऐसी कौन सी संख्या है जिसे 36,798 में से घटाने पर प्राप्त की गई संख्या 78 से भाग हो? तो देखिए जी, just divide this 36798, you divide this by 78. Okay, let's do this. Divide this by 78. Okay, so 78 into 5, 80 into 5 is 400. So no, it won't go by 5. So goes by 4. Alright, so 8 4s are 32, 7 4s are 28. That is 31. So 5 5, 9. 7 8s are 56. So goes by 7. Alright, so 7 8s are 56, 7 7s are 49, and 5 54. So you get a 13. Alright, you take a 1. So goes by 78. So left over here is 60. So 60 is that number. If 60 you subtract from 36798, then you get a number which is divisible by 78. Obviously, I mean, this is the remainder. This is, what is remainder? Remainder is extra. You know, the extra amount, because it is something which cannot be included in the divisible component. तो ये 60 जो है ये extra आ गया जी, यही हटा दीजिए आप इसमें से. Alright, so that is the answer. If you reduce 60 from 36798, you will get a number which is divisible by 78. Alright, starting with LCM and HCF, least common multiple, highest common factor, लघुत्तम समापवर्त्य and महत्तम समापवर्तक. So what is LCM? You know, smallest number which is completely divisible by the given numbers, and HCF, you know, is the highest number which completely divides the given numbers. Alright? Well, simple things actually. Find out the LCM of 10, 15, 20. You've done time and work also. So what is the issue? You already know 10, 15, 20. Alright, so take the table of 15. Next is 30, not divisible by 20. Alright, then you have 45, then you have 60. Yes, that's it. That is actual method. But then if at all you want to elongate it, then this is going to be 2 into 5. Then 15 here is 3 into 5. Then 20 here is 2 square into 5. So when we take LCM, we always take the highest power. So highest power of 2 is 2. Highest power of 3 here is 1. Highest power of 5 is 5. So while doing that, we separate out 2 and 5, if at all you have. So 2 into 5 and then 2 into 3. So this is 10 into 6. You get a 60. But that table wala process that I told you for such close numbers is much easier actually. Finding out the HCF. What do? When you have to find out the HCF, you always take the lowest or least powers. Now 2 here is not common here. No? It is not here. So if 2 is not present here, what is the power of 2? 0, which is 1. 3, is 3 common here? No. What is common? 5, least. So it is 5, obviously, it has to be less than 10, no? Alright, it cannot be greater than the least number. It can be equal to least number, but it can never be, HCF can never be greater than the least number. So at the most it would have been 10. If the numbers would have been 10, 20, 30, then HCF would have been 10. But it says 10, 15 and 20. 15 is not divisible by 10. 10, 20, 30, 20, 30 are divisible by 10, so 10 is the HCF. 10, 15, 20, these three numbers are divisible by 5. So quite easy and quite simple. Alright, now these numbers. Now you have 4 such numbers, see 18, 28, 108, 105. Isn't it so? So it makes sense if at all you prime factorize them. So this is called prime factorization. So if you remember, you used to find out the LCM like this, isn't it so? Some of you still prefer this, 18, 28, 108, 105. Again, very obsolete kind of a method actually. It's a very general, conventional method, alright? But what you could have done is 18. How many 2's are there in 18? Powers of 2. Divisible by 2? Yes. Next power of 2 is 2 square. So 4. Is it divisible by 4? No. So divide this by 2. What is left? 9. So it is 2 into 3 square. Absolutely fine. 28. Divisible by 2? Yes. Next power. Divisible by 4? Yes. Next power. Divisible by 8? No. So there are only 2 2's here. So divide by 4. 4 7's are. So you get a 7 here. Alright. Then you have a 108. Divisible by 2? Yes. Divisible by 4? Yes. Divisible by 8? No. Okay. So once again 2 square. So divide this by 4. So 4 2's are 8, and then you have a 20. Then you have a 28. 2 left over. So you get a 8 down. So 28 is what is there. So it should go with 8 in that case. 4 2's are 8. So it goes with 8. 8 1's are 8. 28. No, it does not. Divide this by 4 anyhow. 4 2's are is 8. So you are left with now 28. So you should be getting that is 12 into 9, isn't it? So I think 7, 4 7's are 28, right? So you get a 27, which is nothing but 3 cube. Next here is a 105. Divide this. Goes by 2? No, it's not even. Goes by 3? Yes, definitely. Goes by 9? No. 3 square it does not. So goes by 3. So start with 3. 3 3's are 9. 15, so 5. 35. So it is 3 into 5 into 7. That's it. Alright. So let us find the LCM. Take the highest power of 2. Highest power of 2. 2 square everywhere. Alright. Then you have highest power of 3. 3 cube. Highest power of 5, 5 is appearing only once, so into 5. Highest power of 7, 7 is appearing only once, so this is 7. So I'm keeping 1, 2 and 5 separate. Now I'm left with a single 2 here. Okay, 3 cube is what? 27 into 7. So this is 10 into 54 into 7. So a 0 here, 7 4's are 28, 7 5's are 35, 37. Alright, so 3780 is the LCM. Now you want the HCF. HCF, if you want, take the least power, common power. 2, 2, 2, no 2. So 2 cannot come here. In all the 4, if there is something common, see, 3, no 3. Okay. Then 5, no, don't have 5 here. 7, no, don't have 7 here. HCF is 1. That's it. Okay. So as simple as that. Now, the traffic signal lights of 3 different roads change after every 48 seconds, 72 seconds and 108 seconds. If all the 3 change together at 8:20, then at what time will all the 3 change together again? Okay. So basically you have to find out the LCM of 48, 72 and 108. That's what you need to find out. Okay. So finding out the LCM of these numbers, 48 Is it divisible by 4? Yes, 16 to the 2 to the power of 4. So this here is 2 to the power of 4. Let us say these all are should be divisible. Okay, anyhow. So let me take it as 2 power 4. Okay, that is 16. So 16 into 3. Okay. Now goes by 8 definitely, but does not go by 16. So it is 2 power 3, 8 into 3 square. Yes, 9, 8 9s are 72. 108, again it goes by 4, all right. So you have a 4 that is 2 square into 3 cube. Yes, 36 into 3 as you know. So LCM if you need to find out, take the highest power, see 2 power 4, okay, into 3 power 3. I can also write this as 2 power 3 into 3 power 3 into 3, sorry, into 2. You know, 1, 2 I have taken from here, from 4, 3 here and 1 here. Why? Because this is nothing but 6 power 3 into 2. This is 216 into 2, which we know is 532. But what are these 532? These are seconds. Convert them into minutes. So 532, there are 60 seconds in a minute. All right. So 8s are 48. Okay. So you get a 52. So once again, what we have here is a 52. Correct? These are 532 seconds, no? So I should be adding 8 and 52 seconds, right? All right. So here we had 8:20, 0 seconds, adding 8 minutes and 52 seconds to this. We got 8:28, 52 as the next time when all the three will change together after 8:20. All right. So I think this is quite clear to everyone. Okay. Sorry, my fault. I'll just correct myself before you say something. Just a minute, just a minute, just a minute. So we get a 216 into 2. All right, that is 432 actually, not 532. So that I divide by 60, goes by 7. All right, right. So 420 and you get a 12 here. So this is 7 and 12. So next time they will change at 8:27 and 12, right? Okay, happens. Never mind. Now look at this number, this question. And now questions like these have appeared aplenty in IBPS PO and other PO and clerk examinations, banking examinations. Which smallest number divides 20, 25, 35 and 40 and leaves remainders 14, 19, 29 and 34. Now, which smallest number, it is not divides, it is when divided by 20, 25, 35 and 40 will leave these remainders. All right. So here what you should do is take LCM of these numbers 20, 25, 35 and 40. But make one observation. See 20, 25, 35 and 40. Remainders here. See these are what? Divisors. Remainders here will be 14, 19, 29, 34. So this will be 6, 6, 6, 6. Here you see that the difference happens to be the same. Difference is the same or not? Okay. So now what you have to do is you will have to subtract the difference from the LCM of these numbers. Okay. That is nothing but 6. Okay. So whenever you are having divisors like A, B and C, which when divide a number leave remainders X, Y and Z respectively, such that a minus x equals b minus y equals c minus z equals a difference d, then take LCM of ABC and reduce the difference from them. So that's exactly what we are going to do here also. Okay, 20, 25, 35, 40. All right, let's take it up. So quite simple actually, but then if at all you still have a problem, this is nothing but 2 square, 4 into 5. Okay, 25 you know is 5 square. 35 you know is 5 into 7. 40 you know is 2 cube into 5. So you have a 5 here. So 2 cube is the highest, but I would write this as 2 into 2 square. 2 into 5 I will take no first. 2 into 5 into 2 square. Alright. Why even that? We have a 5 square here. Isn't it so? Okay, so what I'm going to do is 2 square into 5 square, which is 100. Which is 100. Okay, so left over here is 1, 2. Okay, and the other one, we don't have a 3, we have a 7 here. So this is 100 into 14. 1400 minus 6, so the number is 1394. If you want, you can try. 1394 if you divide by 20, okay, the remainder obtained will be 14. Obviously, it will go up to 1380. If you divide by 25, remainder obtained will be 19. Obviously, 1375, remainder is 19. Divided by 35, remainder obtained will be 29. So obviously, you have a 65, 1365. All right, then divided by 40, all right, then remainder obtained here is 34, 1360. Okay, so likewise, quite simple for you to find out. So these are important questions here. Okay, this is anyhow the answer solution. Okay, 28 and 32. Now there are two methods. Actually, I explained one to you. That was prime factorization. Now the other is called long division method, in which what do? You divide the larger number by the smaller number. Then whatever the remainder you get, okay, what you do is you take the divisor, first divisor here, okay, and divide it by the previous remainder. If at the end you get 0, then in that case the last divisor here will happen to be your HCF. Okay, so simple method here. Otherwise you could have taken prime factorization also, that's not an issue. So you could have done this by continuous division also, long division method. Find out the HCF of 493 and 928. Now prime factorization might be a little tough. So what do? So 493, 928. Alright, goes by 1 only, so 493. We are not bothered about quotient here. So 5 and this is 3 and this is 4. So 435 and 493. Again 435 goes here, 13 minus 5, that is 8. 8 minus 3, that is 5. 58, 435. Okay, so 60 if I take, so 7 6 it goes by 7 I believe. 7 6 8 6 42. So can it go by 8? Yeah, it does. 8 8 64. 8 5 40. No, it doesn't. 8 6 48. No, so I can't get this one. So goes by 7. 7 8 56. 7 5 35 and 5 406. So 9 here and 2 here. 29. You get a 58, which is divisible by 29. So 29 here becomes the HCF. There we go. All right. Now anyhow, these are very starter kind of questions, isn't it so? Just to get the feel of this. So even I'm omitting that. 100, 120, 125. Again, by continuous method, division method, you can find this. All right. Now for fractions, you should know. LCM of fractions is LCM of numerator by HCF of denominators. HCF of fractions is HCF of numerator by LCM of denominator. Whatever you want to find out, that should be here, okay, in the numerator and the other in the denominator. What other? I mean, we are talking only of two things here, LCM, HCF, okay. Now, what is the LCM and HCF of 1 by 3, 2 by 9, 5 by 6 and 4 by 27? See, LCM of fractions, LCM of 1, 2, 5, 4, which is 20. HCF of 3, 9, 6, 27, that is 3. So 20 by 3 will become the LCM. And HCF of fractions, so HCF of 1, 2, 5, 4, 1 only. LCM of 3, 9, 6, 27, 54. Okay, so 1 by 54. So that's how you could have found out LCM of fractions or HCF of fractions. Now, very important rule, you have learned this, obviously you have learned all these things in your earlier classes, because we are talking about whatever that you have learned in 8th, 9th, at the most 10th standard. That's it. Nothing beyond that is coming in the examination as such. Alright, so we are just revising 8th, 9th, 10th standard classes. Okay, so that is the basic maths level which is required for all the entrance examinations, I would say, almost. So LCM into HCF is first number into second number. If you want to find if you have two numbers given to you, A and B, then the product of their LCM and HCF is the same as the product of the two numbers. All right. Also, very important, LCM is equal to HCF into product of co-primes. We will be solving a question based on this, don't worry. All right. So LCM is equal to HCF into product of co-primes. An important expression formula, please do memorize and note it down. All right. Now, if for two numbers, their co-prime factors are A and B, let us say, and their HCF is H, then the two numbers will be HA and HB. HCF is a number which will divide both A and B, no? Isn't it so? Now, the numbers here will become HA and HB. So, numbers are being divided by H. These are the co-prime factors, A and B. How? Hold on. We'll have a look at the question to know better. Straight question. HCF of two numbers is 11 and their LCM is 7700. One of the two numbers is given to you, 275, then the other number will be. So, you know that LCM into HCF is equal to the two numbers, A into B, whatever, or X into Y, whichever way you want. Okay. Now, I am used to X into Y, so let's put it as X into Y. No hassle. Because A and B we are using as co-primes here, no? So, let's not confuse. So, LCM here is 7700, HCF is 11 and the number here is 275 into Y. That is the second number we have to find out, that is Y. Now, very simple for you to know that 275 is a number which is divisible by 11. How? Well, 2 plus 5 is 7 and this is 7. So, difference here is 0. So, 11 cuts this, 2s are 22, 55, so 5s are. Alright. So, what you basically get here is a 77 into 100, okay, divided by 25. So, goes by 4. So 7 4s are 28, 7 4s are 28, 308 is the other number. Okay. So, that was just substitution of the formula. Just a minute. Now, two numbers are in the ratio 3:4 and their HCF is 4. Then the LCM of the two numbers will be how much? Now, see here. Two numbers which are in the ratio 3:4. I can say that the two numbers here are 3H and 4H. Okay, HCF is already given. Okay, let us say the numbers here are X and Y. Alright, so they would be 3H and 4H. HCF is given as 4, so 3 into 4. This is what? 4 into 4. So the number here is 12 and 16 already given to us and their HCF is given. So LCM is what you need to find out. No, you know the numbers now, you know the HCF also. So employ this formula. Nothing needs to be done here. Okay. So that's all that you have. LCM into HCF is equal to X into Y. So this is 12 into 16. HCF here is 4. So LCM is the only thing which is remaining. 3s are, so L here is 48. That is the LCM of 12 and 16 anyhow, you know. Okay, so no need to put into formula also. Now again, LCM of two numbers is 48 and the ratio between the two numbers is 2:3. Now what will be the sum of the two numbers? So the ratio between the two numbers is 2:3. HCF is not given. HCF is not given here. So now you remember the formula. LCM is equal to HCF into the sum of or product of, in fact, the two numbers, the co-primes as we have. So 2H and 3H is what you have. So product of co-prime factors here, that is nothing but A I am taking as 2H, B I am taking here as 3H. Alright. So HCF, LCM is 48, HCF is unknown into product of two factors. Alright, what are those? 2 and 3, that is 2H and 3H. Alright, so you can say that. So basically it will become, you can have it in that particular formula also, no? LCM into HCF is equal to 2H into 3H. So these H here will cancel. LCM is given as 48, okay? Now that is 6H. So H here is nothing but 48 by 6. Alright, now that is 8. So when you have it as 8, this number is 16. You have it as 8, so this is 24. So the sum of the two numbers here will be 40. Alright. Now three numbers are in the ratio 3:4:5. See, the level has risen. Again, your IBPS PO question only this. Three numbers are in the ratio 3:4:5. And their LCM is 2400. What will be their HCF? Alright, see, let the numbers here be 3H, 4H, 5H. Why? Because each of the numbers will be a product of, or let us say a multiple of the HCF. जो हर एक संख्या यहाँ पर दी गई है, भाई वो अपने HCF से तो भाग होगी. तो 3H आ गया, 4H आ गया, 5H आ गया. LCM आपको दे रखा है already 2400. Alright, so LCM, यहाँ पे अगर आप इनका LCM निकालेंगे, LCM of these three numbers, 3, 4 and 5, that is 60H. And LCM is already given to you here as 2400. So 60, 40, that is your HCF very easily. You could have got it. Alright. Okay, moving on. Which number between 1500 and 2000 is divisible by both 36 and 102? Divisible by both 36 and 102 means you will have to find out the LCM of 36 and 102. Isn't it so? So 36 as such, you know, is 6 square. So 2 power 2, 4 into 9. Okay. 102. Well, goes by 4. Is it? No. It only goes by 2. Why? Because it is 2 into 51. 51 is 17 into 3. Right? So 2 into 3 into 17, that's all that we have. So LCM that we get here will be 2 square into 3 square into 17. Isn't it so? So that is 36 into 17. So 17 into 6, you know, is 102. So you have a 2 here, 10 left, 17 into 3 is 51, so 61. 612. Now, but you have to find out the number between 1500 and 2000. Now, 612 is not between 1500 and 2000. Isn't it so? So, I will take the next multiple of 612. Which number between 1500 and 2000 is divisible by both 36 and 102? So, it is basically 612K, the multiple. So, 612 into 1, 612 is not between 1500 to 2000. So take the next multiple, 612 into 2. No, it's 1224. Again, not between. So the third multiple here will suffice. So 6 3s are 18, 12 3s are 36. Okay. So 1836 is the answer that we get here. So we have completed everything right on time. All right. So that was number system, and in that we had also included LCM and HCF. Okay, so we will meet again tomorrow with, well, one of the most sought after, one of the most important, one of the most interesting topics, syllogism, in which I will teach you a technique how to solve questions based on syllogism without using Venn diagrams. So Venn diagrams will not be required, although I will teach you both the processes, with Venn diagrams, without Venn diagrams. But you don't need Venn diagrams actually. And it will be a much faster approach in which you will be able to solve the questions within 10 seconds to 15 seconds. So syllogism पे आधारित जो प्रश्न होंगे 10 से 15 सेकंड में आप सॉल्व कर पाएंगे. तो कल दोबारा मुलाकात होती है. Till then, I Kapil Datta sign off and I wish you all the luck. Do well, stay safe and work hard. Thank you so much.